116, longest palindromic subsequence. So for this problem, it is a little bit similar to longest palindromic substring. The only difference is that this is a subsequence. So, for example, if we are going to calculate a substring like BBBAB, yeah, if it is a palindrome substring, it's going to be something like BBB. But here we are going to calculate the subsequence, so it's going to be 4 bits, so the result is going to be 4. Yeah, although it is the dynamic programming idea, but it's going to be a little bit different from the Leetcode problem 5, longest palindromic substring. Yeah. So the idea is that this is our string S. So this is the whole problem. So for example, this is the index I and this is the index J. We are going to calculate how many. We are going to calculate the longest palindromic subsequences. So the definition of the dynamic programming is going to be Fi to j. If we are going to calculate Fi to j, actually this I is going to be 0 and j is going to be n minus 1. We are going to calculate F0 n minus 1. If we are going to calculate this problem, normally it means the subproblem has already been solved. Yeah. So this is the basic idea. But for the DFS with memorization, it's going to always be easier to understand. So let's just try to solve in this way. So we're going to use DFS with memorization first to solve it. So we're going to define a DFS. And inside, it's going to be 2 indices I and j. And we're going to return the function with DFS from 0 to less of the string minus 1. So this is our definition. So we are going to check what is the longest palindromic subsequence from index 0 to n minus 1. Yeah, so let me just yeah. So the condition is that I gonna always be less than or equal to j. But if I is more than j, it is not possible we're gonna return a 0. If I equal to j, this means we find 1. This means the length is going to be 1, so we're going to return 1. So for example, I equal to j for this character b, definitely it's going to be a palindrome. So the length is going to be 1, so we're going to count it as 1. It's I equal to j. Now we're going to check the 2 different cases. If si equal to sj, so we're going to check the subproblem. Yeah. So here we're going to prepare a result. It's going to be 0. So the subproblem is going to be result plus equal to with DFS. So what's going to be the subproblem? It's going to be I plus 1 to j minus 1. So this is the subproblem. Yeah. So this is one case. If they are equal, the subproblem gonna plus a 2. So for example, this b equal to this b. Here it's going to be 2 plus the subproblem BBA, and this BBA is going to be a 2. So the result is going to be 4. Yeah. But this is for calculating the subsequence. We're going to check the else case. If they are not equal, we're going to still check it. So the result is going to plus equal to the maximum of the 2. So let me just copy the code from here. So the maximum of the 2. So here we just needed to remove this minus 1. Here we're going to remove this plus 1. And finally, we're going to return the result. Now let me just run it to check and submit it. Yeah, as you can see, it works because we used the memorization. That is why we can pass. The time complexity going to be n squared. N is the length of the string. Now we're going to turn this kind of DFS with memorization to the real dynamic programming. But how can we do that? So we're going to prepare the length of the string, and we need to prepare a DP table. So we're going to set a 0 times n for anything in range n. Our final return is going to be 0 to n minus 1. It's going to be exactly the same, 0 to n minus 1 here. So there are going to be 2 conditions, this one and this one. Yeah, but we don't need to use this result because this is the DP table. We need to, yeah, but definitely we're going to use 2 for loops. This means we need to solve the subproblem first before we are solving the whole problem. Yeah, according to this way, we're gonna write the two for loops. So for I in range, so we're gonna check from the right to the left, n minus 1, minus 1, and minus 1. So this is gonna be the subproblem for j in range I plus 1 to n. Yeah, so this means if B is solved, now we are going to check AB and BAB and all those cases. Before we are checking this left B and right B, all the subproblem has already been solved. This is why we can use it directly. Let me explain it. So for example, if we have something like BBB, AB, if we are going to check the F0 to n minus 1 here, so this is our subproblem. Actually, this subproblem has already been solved, but why it has already been solved? Because of the two for loops. Yeah, this two for loops is from the right to the left. This B already be solved, AB already solved, BAB already solved, and BBAB already solved, and definitely BBA has already been solved. Why? Because while we are checking this 0 to n minus 1, this is I. This I can be n minus 1, but this I can also be n minus 2. Yeah. If this I yeah, now we are going to check 0 to n minus 1, but for this subproblem, this is 1 and this is n minus 2. Yeah, so definitely this subproblem has already been solved. Why it has already been solved? Because of the two for loops. So this is first of all it is n minus 1, and then it is n minus 2, and then it can become 1. So here it can the first for loop, the index can become 1, and for the j it can become n minus 2, and this has already been solved. Now we are going to check this one. The last one is going to be 0, and 0 to 1, 0 to 2, and 0 to n minus 1. So finally, our whole problem has already been solved. So this is why we're going to design the two for loops like this. Because we are going to check 0 to n minus 1, this means everything inside has already been solved. So this is why actually the DP table going to be the DP table going to be something like this. So this is our DP table, and we are just checking this kind of a rectangle. If this one has already been solved, the whole problem has already been solved. But we are going from the bottom up. So this is the bottom up. Yeah. While we are calculating the bottom, and the final one going to be this one, the top layer. This layer definitely can be solved because all the bottom layer has already been solved. Yeah. Now it's going to be similar like here. We're going to check the two different cases, but before that, there's a special case. It means the edge cases. While we are preparing this kind of programming, this is the edge cases. If I equal to j. Yeah. So fi and I going to equal to 1. Because if a character for this character b, what's going to be the longest subsequence? Definitely for this character b, it's going to be 1. So this is why we're going to set it as 1. Now there are going to be two conditions. If si equal to sj, we're going to update the fi and j. It's going to be fi plus 1, j minus 1 plus 2. Else, let me just copy it. So it's going to be the two cases. It's going to be the maximum of the two cases. Yeah. So I plus 1 to j and I to j minus 1. It's going to be the maximum of the two. Yeah. So for example, we have BB, maybe CB. What's going to be the longest? Yeah. So one case is this B equal to this B. what's going to be the longest BC? It's going to be 1 plus 2, it's going to be 3. So another case is that this is going to be BBC, but here is C. So what's going to be the longest? Because this B is not equal to this C, so we're going to check the two subproblems. This is one BBC, another one is BCC. And finally, we're going to return 2 as the longest palindromic subsequence. Yeah. So I think that's all about it. Let me just run it. As you can see, it works. Let me just delete this area and submit it. As you can see, it's pretty fast because this is a real dynamic programming. But for most of the cases, maybe we can use DFS with memorization first. If it is okay, definitely we're going to use it. Otherwise, we're going to use the real DP. Because this is just a 2D table, normally it is not so difficult. It is not like 3D or 4D. It is just a 2D DP table. It can be solved. Yeah, we just need to know the edge cases and the formula, how to check it if they are equal or not equal. I think that's all about it. Thanks for watching. See you next time.